Hello everyone, myself Ankur Patel, and today in this session of engineering course we are going to discuss Directrix and focus method to construct an ellipse, parabola and hyperbola. But before moving on to method, let us discuss the definition of ellipse, parabola and hyperbola in terms of a fixed straight line and a fixed point known as focus point. So ellipse is a locus of point moving in a plane such that the ratio of its distances from the fixed point to a fixed straight line will remain constant and less than 1, and this ratio is known as the eccentricity ratio, and it will be less than 1 for ellipse. Here fixed point is known as the focus point and fixed straight line is known as the directrix. So this will be the fixed straight line directrix, this will be the conic axis, and this will be the fixed point focus point. So in the definition it is given that ellipse is a curve traced out by a point moving in a plane such that the ratio of its distances from the fixed point to a fixed straight line will remain constant, it is less than 1, and this ratio is known as eccentricity ratio. The ratio of moving point to fixed point to moving point to fixed straight line, this ratio is known as the eccentricity ratio. Now parabola. Parabola is a locus of point which moves in a plane such that the ratio of its distances from fixed point to a fixed straight line will remain constant and equal to 1, and this ratio is known as the eccentricity ratio. It will be equal to 1 for parabola. So in the figure you can see that this will be the parabola, ratio of distances of moving point to focus and moving point to fixed straight line, and that ratio will be equal to 1 for parabola. Then after hyperbola, it is a locus of point which moves in a plane such that the ratio of its distances from fixed point to a fixed straight line will remain constant and greater than 1, and this ratio is known as the eccentricity ratio, and it will be greater than 1 for hyperbola. So this will be the hyperbola and this will be the moving point, and the ratio of distances of the moving point from fixed point to fixed straight line will remain constant and it will be greater than 1 for hyperbola. Now when this curve, whether it will be ellipse, parabola or hyperbola, intersect the conic axis, then the point of intersection is known as the vertex point. So vertex point is the point of intersection of curve and conic axis. So this will be the vertex point. So we can also give the definition of ellipse, parabola, hyperbola in terms of the vertex point. So eccentricity ratio is also defined as the ratio of fixed point to vertex point to directrix. Okay, so the eccentricity ratio E for ellipse is less than 1, and we can say that VF upon VR, V is the vertex point, that means distance of vertex to focus to vertex to directrix, it will be less than 1 for ellipse. This ratio is equal to 1 for parabola, and it will be greater than 1 for hyperbola. So now let's move on to Directrix and focus method to construct an ellipse. So the content is given here. Construct an ellipse when the distance of focus from Directrix is given, it is 50 mm, and the eccentricity ratio is 2/3. Draw the tangent and normal to ellipse at given point. So first of all, given data, eccentricity ratio is given, it is 2/3, and as we know that eccentricity ratio is the ratio of distances from focus to vertex to fixed straight line, that is directrix. So it is 2/3, and the distance of focus from directrix is given, it is 50 mm. So divide this distance into 5 equal parts, that means 2/3 is equal to 5. So divide this distance into 5 equal parts. So we will get V1 to F1 is equal to 2 units, so it will be equal to 20 mm, and V1 to R1 is 3 units, so we will get 30 mm, as we have to divide this line into 5 equal parts. So we will get 2 units for V2F distance and 3 units for V2R distance. So for 2 units we will get 20 mm and for 3 units we will get 30 mm. So first of all, draw directrix and conic axis. After drawing directrix and conic axis, mark these points, that is here will be R1, and from R1 to V1, so the distance between V1 and R1 is equal to 30 mm, so mark V1 at 30 mm from R1, and the distance between V1 to F1 is 20 mm, so mark F1 at 20 mm. So after marking these points, draw a line perpendicular to the conic axis from vertex point. Okay, and after drawing this line, now measure V1 F1 on the rounder and give an arc on this line and mark this intersection point as Q1. Connect Q1 to R1. This angle will be less than 45 degree. After drawing this line, from focus point F1, draw a line inclined at an angle of 45 degree to the conic axis. So draw a line inclined at an angle of 45 degree to the conic axis. This line will intersect this line at this point. So mark this point and draw a line perpendicular to the conic axis from this point. So this will be our vertex point V2. Now measure V1 F1 and from V2 mark F2. Measure V1 R1 and from V2 mark R2. So from R2 we will get Directrix. So after doing this, now make divisions in between V1 and V2. So you can divide it randomly. It is not necessary to divide V1 into V1 to V2 into equal number of divisions. So mark divisions randomly. 1, 2, 3, 4, 5, 6, 7. After dividing this, now draw lines perpendicular to the conic axis or parallel to the directrix from these points. Okay, and mark the intersection point of these lines to this line, RQ line, as A, B, C, D, E, F, G. So after doing this, now measure 1 to A on the rounder or measure the arc length of 1 to A, and from F1 as the center, give an arc on this line on both sides. You will get P1 and P1 dash. Now measure 2B or measure the arc length of 2B, and from F1 as the center, give an arc. You will get P2 and P2 dash. Now 3 to C, measure arc length of 3 to C. From F1 as center, give an arc on this line, both sides. You will get P3, P3 dash. Now measure 4 to D arc length, and from F1 as the center, give an arc on both sides. You will get P4 and P4 dash. Now measure 5 to E arc length on the rounder, and from F1 as the center, give an arc. You will get P5, P5 dash. 6 to F arc length, from F1 as the center, give an arc. You will get P6, P7, P6 dash. 7 to G as arc length, and from F1 as the center, give an arc. You will get P7, P7 dash, and last one will be our V2 point. Now connect this point with freehand curve. You will get an ellipse with Directrix and focus method. Now we have to draw the normal and tangent to ellipse at given point. So first of all, mark this point anywhere on the curve. So let us say that mark point S over here. Now connect this point to focus point, or draw a line from S connecting F1. Okay. After drawing this line, now draw a line perpendicular to this line from focus point and in the direction of the Directrix, and the intersection point will be T. Now connect this point to S will be our tangent, and a line perpendicular to the tangent from point S will be the normal. So this is the Directrix focus method to construct an ellipse. Now let's move on to Directrix focus method to construct the parabola. So construct a parabola with distance between focus and Directrix is 40 mm. So right now the distance of focus from the Directrix is given, it is equal to 40 mm, and as we know that the eccentricity ratio for parabola will be equal to 1. So we can say that V2F the distance of focus from the vertex and the distance of vertex from the directrix will remain same. So VF will be 20 mm and VR will be 20 mm. VF is distance of focus from vertex is equal to 20 mm and VR is equal to distance of vertex from directrix. It will be also equal to 20 mm. So now first of all draw directrix, then after conic axis, and from the directrix at the distance of 20 mm and 20 mm mark the points vertex point and focus point and R. So right now the distance of vertex from directrix will be 20 mm and distance of focus from the vertex point will be 20 mm. So after marking this point, now we have to draw a line perpendicular to the conic axis from the vertex point that we have already drawn. Now measure V2F on the rounder or V2F arc length on the rounder, and from V as the center give an arc. You will get this point, connect this point to R, and this point is our Q point. So connect this point to R and draw a line. The angle of this line will be equal to 45 degree for the parabola. So after drawing this line, make divisions from V2 in the direction of focus. So mark divisions and draw lines perpendicular to the conic axis. So this will be 1, 2, 3, 4, and the intersection point of these lines to RQ line will be A, B, C and D. Now apply the same method that we have applied in the ellipse. Measure 1 to A arc length, and from F as a center give an arc on this line on both sides. Now measure 2 to B on the rounder or 2B arc length, and from F as a center give an arc on both sides. Now 3 to C on the rounder, or measure 3 to C arc length on the rounder and give an arc from the focus point on both sides. This point or this arc will intersect on this line. Now measure 4 to D arc length and from F as a center give an arc. We will now mark these points P1, P2, P3, P4. Mark this point P1 dash, P2 dash, P3 dash, P4 dash, and draw a freehand curve passing through this point will be the parabola with directrix and focus method. Now if you want to draw a normal and tangent at any point on this curve, so mark that point first of all as. Now make sure that the method to draw normal and tangent in directrix and focus method will remain same in ellipse, parabola and hyperbola. So mark that point, connect this point to F, draw a line perpendicular to this line from focus point in the direction of directrix, mark the intersection point and draw a line joining this point to point S. This will be our tangent, and a line perpendicular to the tangent and from point S will be a normal. So this is the directrix focus method for parabola. Now let's move on to directrix focus method to construct the hyperbola. So hyperbola by directrix and focus method. So content is given here. Draw a hyperbola having eccentricity 8:5. The vertex V of which is at a distance of 20 mm, 25 mm from the directrix AB. Find the distance of the focus F from the directrix. So first of all, let us write down the given data. Eccentricity ratio E is equal to 8/5. So eccentricity ratio is the ratio of distances from focus to vertex to fixed state line. So it is equal to 8:5. So right now the distance of vertex from the directrix is given. It is equal to 25 mm. So V to R is equal to 25 mm. So put 25 mm in this equation. You will get VF is equal to 8/5 into 25 equal to 40 mm. So the distance of vertex to focus is equal to 40 mm. And here it is given that find the distance of focus from the directrix. So the distance of the focus from the directrix will be summation of 40 plus 25. It will be equal to 65 mm. Now first of all draw directrix, conic axis. After drawing the directrix and conic axis, now mark this point. So from the at the distance of 25 mm from directrix and 40 mm from the vertex point, you will get focus point. So from Directrix at the distance of 25 mm you will get vertex point, and from vertex point at the distance of 40 mm you will get focus point. After drawing the focus, vertex and R, draw a line perpendicular to the conic axis from the vertex point that we have already drawn. Now measure V2F arc length on the rounder, and from as V as a center, give an arc on this line. The intersection will be point Q. Now connect this point Q to R and draw a line. The angle of this RQ line will be greater than 45 degree for hyperbola. And after drawing this line, make divisions from V in direction of F. So make divisions 1, 2, 3, and from the divisions draw lines perpendicular to the conic axis. So this will be 1, 2, 3, and the intersection point of this line to RQ line will be ABC. After marking this point, now measure 1 to A arc length on the rounder, and F as a center, give an arc on both sides. Now measure 2 to B arc length, and from F as a center, give an arc on both sides. 3 to C on the rounder, give an arc from F on both sides. You will get these points. Mark these points P1, P2, P3, and P1 dash, P2 dash, P3 dash, and join these points with freehand curve. You will get the hyperbola with Directrix and focus method. And if you want to draw a normal and tangent in Directrix and focus method, the method will remain same that we have discussed in last two sums. So this is it for today. Thank you for watching. See you in the next lecture.